Hello again. Hello, happy Sunday, SuperCon. How is everyone feeling? Are you full of food now and ready for our next talk? I would like to hear a little bit of noise. I want to know you're awake. Just something? Thank you. I appreciate that. Good, good, good. Everyone is feeling a little bit refueled now and ready for our next talk. Now, our next speaker is a software engineer specializing in data security. But outside of work, they enjoy hands-on creative projects that blend code, aesthetics, and physicality, like machine embroidery, textiles, and other tangible hacks that make tech feel more personal and beautiful. I think this sounds like a wonderful premise for a talk, so please put your hands together and welcome to the Hackaday Super Conference stage, Kay Antoniak.
Okay, thanks. So hey, it's Kay, and I wanted to talk about embroidery today, specifically the type that you can do at home or in a makerspace, so something that's like much more approachable for like a regular person. And now, why would you be even interested in that, right? There's one thing that comes into my mind that is embellishment, like adding decorations to stuff, but adding your own logo to different things. Like maybe it could be a part of just like a case of your next project. But there's also other uses to that. So one thing is that you can introduce new interfaces to what you already had and like a new way of talking to your device or project or so. There's also some other more interesting things. So for example, you can embroider antennas. So you can make an NFC antenna on your thing, like non-planar antenna or so. And there's also more elaborate uses. You can go kind of crazy and like make a heat pad, make a speaker, like making a calls from the thread or so. Yeah, but now how do we start, right? I think we'll do this in 3 sections. Like we'll try to blaze through the basics, then like look at making your own stuff and maybe using some more advanced techniques. So just to make sure that everyone is on the same page, like how a sewing machine works, sewing machine, you have 2 threads. One thread is at the top, and this is the one that everyone knows about, but there's also a bottom thread, and the bottom thread goes onto the bobbin, this round thingy that goes beneath the presser foot. So actually, when machine is stitching, it's trying to lock between those 2 threads. So you have a mechanism that's moving, advancing the fabric, right? And the needle penetrates, it makes a loop, and it keeps going forward. And this is how you make a stitch. One thing that's really important in here is that you have back stitches. Like back stitches is something that prevents unraveling at the beginning and at the end, right? And that's pretty much how a sewing machine works. Now, how an embroidery machine works. Embroidery machine is pretty much a CNC. It's like very similar to a 3D printer or so that you would have. The main difference is that this whole mechanism that we had in the middle, it gets swapped for a hoop, and the hoop holds your fabric. So now, when your fabric is being held in place, you can really start moving the arm within the whole assembly that machine provides. So basically, you have an XY plate in here, right? And you can still start stitching. And there's a bunch of commands. And this is really interesting because this is very similar to a 3D printer again. You have like a kind of G-code, right? And you can generate a set of commands that would stitch in different places, like a stitch in place A, stitch in place B, and you suddenly have a line, and you have a full control over this. One thing that needs to be taken into account that there is actually, this is not a proper G-code, this is like proprietary formats that are developed by different companies. So you have to generate code for different machines, especially when you like try to code something on your own. Okay, and I just wanted to make a point of the fact that there might be already an embroidery machine in your makerspace. So like go to your makerspace, make a note of the machine number, and many machines have this special arm. So you can like detach the base arm and make it an embroidery machine, right? On top of that, like when you have verified this, it's actually very affordable to try, and we'll see that you can make your own stuff for free pretty much. So one thing that you would like to check on is you need a bunch of supplies. So again, like following on this analogy to a 3D printer, you need your fabric, but like you need your filament, right? You need to stabilize the plate. You need to, you need glue. You need like different types of nozzles and so on and so on. So in here, you need like select a stabilizer for a fabric, you need to select the right needle, you also need some thread. But the good thing about this is that it's actually really easy to start, because oftentimes like the stuff that you would already have with a sewing machine is good enough. So you can even go with a cotton thread and a t-shirt that you have lying around and you don't know what to do with, right? Yeah, but once you started, it's fairly easy to run jobs on the machine. I just wanted to go over a few small differences between like a 3D printer and an embroidery machine. So let's assume that you already hooped your fabric and threaded the machine. You can load your designs. There is usually a bunch of built-in designs. And one cool thing is that you have built-in lettering. So you can just like start up the machine and I don't know, add your name on something, right? And it just works. And they are also like properly digitized, so they will work on what you already have. The other thing is that you have USB interface, so you can download stuff from the internet. You can digitize your own. Okay, and once you're done with this, like you can actually arrange the designs, and this is another difference versus a 3D printer. Because on 3D printer, you can't really do much with G-code. In embroidery machines, you can have multiple designs. So you can also like arrange them slightly, make some transformations even, like maybe like flip a design if you want something to be symmetric and so on, right? One thing that I wanted to make a point of, scaling. Because this is G-code of sorts, you might change the density of a design when you are running a design. So when you scale up, it might not cover what you had underneath, or if you scale down, you might start stitching in place, and it will basically become a mess, right? So I think like 80 to 120% like works fine. Yeah. Okay, and you're basically ready to make a design at that point. There is an interface, and it has some basic properties. One thing that's interesting, you will have multiple thread colors. Usually you would have like a one needle machine, so you would change those colors on your own. But there is also another interesting thing, that on many of those machines, you have control over stitch count. So actually, if something gets messed up, you don't have to like start from the beginning. You can just like cut the thread, go some stitches back, and like start from there. So this is really good for like salvaging like your broken prints, right? Okay. And I think this is everything that we need to know about running jobs. Now actually about digitizing. So digitizing is a nice thing that you can do for free nowadays. Historically, the programs were like super expensive to do that. They were like a few $1,000 just for one license. Now someone wrote an extension for Inkscape. So there is this thing called Inkstitch, and Inkstitch is a program that will attach extra parameters to your objects. So basically, you have any vector file, you can start up Inkstitch, and you can start attaching parameters. And then when you export the file in your like selected format for your machine, it will basically run a slicer for you. So that generates the code. Everything, if you have some experience with 3D printers, this should be like fairly easy to get those files generated and run your own stuff. Okay. So I just wanted to make sure that we go over some stuff that's important when digitizing. It's also, again, similar to designing for 3D printing, right? There is some things that you need to take into consideration. So I wanted to go over this patch. This is a vector file created as an example. And we don't really have time to go over everything, but like there's 3 main types of stitches. And if you know how to digitize them, you should be able to like make pretty much what you want. There's 2 important things. One is selecting the right fabric and the right thread. If you, this will dictate what you want to do later with the fabric, because some fabrics have more stretch, right? So they will like pull in more and so on and so on. And there's different parameters that you might want to test. Definitely, if you do a design and it's like designed for one fabric, it might not necessarily work on something else like straight out of the box. You might need to like update some parameters, right? Okay, so we have this vector file. Another thing, designing for size. This is something that you can't easily change because you are designing for a particular density of those stitches. The design that we have here, I selected 70 millimeters. You can't really like go half the size, right? Even if you were go to down the size, like half the size in the program, and you were like going to slice it, this file will just like come out differently because of different compensations and so on. Okay. And the other thing is changing colors, at least on those home machines, when you have one needle. This is a bit of a manual labor, so you don't want to make too many color changes, right? So usually the way that Inkscape works, or Inkstitch rather, works, it's digitizing starting from the beginning of the stack of the visibility in Inkscape, right? So you want to order those things to have like a minimal number of color changes, and also if you have some similar colors, you might want to just like use the same thing, so you have like less things to worry about, right? Okay, so now about those stitch types. So I mentioned that there are basically 3 groups, and every other stitch type comes from the same group. So the first one is running stitch, and then we have fills, and we have satin columns. And I want to go over each them with somewhat more detail, but we'll see this in a second. So the running stitch is the first one. In this patch, it was used in a few places. So running stitch, it has basically 2 categories of use. Usually it's like a very short set of stitches, and you can use them to actually digitize something that would have very little, that would be very detailed, like grass, fur, this kind of stuff. But it also has like a lot of technical uses that would come to my mind when you actually start digitizing, because you want to like go fast when you are actually fabricating your patches, your designs. You might want to move to another place or so, and then all those like travel stitches and other stitches come in handy. So in this patch specifically, the fabric had to be tacked down to the stabilizer. So there's like one loop that we can do, and this loop is not even visible. It's just like a technical stitch, right? We will later go over that loop, and it will not be visible. The other thing is the travel that I mentioned already. Sometimes you want to influence like the order in which the elements are made. So for example, in the wrench here, the core of the wrench was made and the fingers, and then I wanted to go up to the end, so we can start stitching towards the middle of the patch again, right? If you were going to just like jump straight out of there, you would have to like wait for the machine to trim the thread, or maybe you would have to stop the machine and cut it on your own. This way, you can do small stitches that are almost invisible, start doing the stuff, and the machine goes pretty fast, right? Yeah. The other thing is there is those locking stitches. Locking stitches are basically back stitches, but like for an embroidery machine. So you might need to keep things in place, right? So for example, it's not visible here, but you have those red satin columns. So you want to make sure that the satin column is nice and crispy, and the way it's done in this patch, there is like small travel stitches at the beginning, so the lock-in is actually at the beginning of this travel stitch, then it moves to the edge of the satin column, and then it starts the column, right? So all the knots that we would see, they are actually hidden underneath the material. Okay, and for the other type, fill stitch is basically used for a bigger area. I forgot to mention that on a previous slide, but stitches, they have like a limited length. You can't really go too long because the stitches start pulling itself. So like 1.5 to maybe 6 millimeters is the right length. With fill stitches, this is something that you would do when you have actually a bigger area that you have to cover, right? And there is multiple algorithms of filling in those shapes. Basically, the default one from Inkstitch works pretty well, and you can also control a number of parameters that I wanted to mention. The automatic fill stitch in Inkscape, it builds an underlay and then makes a fill on top of that underlay. So there is basically 2 layers, and you can play with those parameters, and this will change the coverage of your fill on the fabric. This is also nice because sometimes you might want to see something that's beneath the main layer. And this is another cool thing about embroidery, that oftentimes you can actually do multiple layers as long as density is not there. There's not too much density, right? Because again, you would start pulling things towards the center, towards the stitch points. In this part specifically, I didn't want to go with like too much density. So this shape, that even though it seems like a continuous fill, it's not continuous, right? So it starts beneath this red satin column that we will see in a second, then it continues towards the center of the patch and goes forward. So now in here, we will only have like a smaller area that's covered by the satin column, but there's basically nothing beneath it. Okay. I already kind of touched on this, but because embroidery is like a high density job, you have a lot of needle penetration in a small area. And this makes the thread that is locking in those places to start pulling towards the stitch line. And you won't be surprised to see that you're trying to embroider a circle, but this circle is actually wider than it should be. That's because it starts pulling in one direction, but it doesn't pull in the other direction. That's because of the field that you have. So that's something that many people don't know about, but there is a setting in Inkstitch, and you can adjust this parameter to increase the coverage in one direction, to widen the part in one direction, so it compensates for that. It might not look great when you try to visualize this, but this is actually something that would come out pretty well in the final design. Another thing that I wanted to make a point of is fill angles. So fill angle can be one like a technical use, because you might want to go against the grain of the fabric. Fabric itself also has some weave, right? So you sometimes have to be like mindful of that. But in here, those different fill angles actually separate different objects, right? So wrench goes like under one angle, and the light bounces off in one direction, and the fingers and other things bounce off in other direction. And we have one more type of stitch, which is the satin column. Satin column is basically a zigzag between two rails. So that's something that you can also do in Inkstitch by setting those two rails. And now there is this underlay that would sit on the edges of the rails, and the zigzag would sit on top of the rail. That's what makes it like nice and crispy and like, you know, sticks out of your design. In Inkstitch, you can control the direction of the ranks, because it's not necessarily obvious for the program like how it should, you know, try to slice the thing, right? For example, in here, this is not a perfect circle. It would just like mess up the angles basically if you were doing this automatically. So that's why you set the ranks, and the ranks go perpendicular to the satin column in that one place. And the slicer will take that into consideration. Okay. Another thing about satin column is that they are nice to be run around fill stitches as a border, basically. The border can be the same color or a different color. So when you have a fill stitch, you can have all this deregistration that I mentioned when things start like pulling in or out, right? And with fill stitches, you can nicely fix this problem. This is useful, especially when you have like different fill areas, maybe in different colors. You know, super neat trick to like make your whatever you're making, make it look better. There's another use. So there is something called appliques. If you didn't know, it's basically when you put a piece of one fabric or material onto the other, and you use the embroidery machine to attach it to the other. So you can even do something that's harder on one piece of fabric when it's easier for you to control, and then when you can actually control it, you finish that piece and you place it on a different thing, and then you would use a satin column to basically attach one to the other. Okay, yeah. So these were all the types, and they pretty much covered everything that was done in this patch, and it's pretty much that you need to know to digitize your own thing. And now when you digitize your own thing, there is a preview in Inkstitch. So you can see like the whole job, how it goes, right? So This one, like, I think it's like 14 seconds, but it basically does everything that I mentioned in here, right? So there's tag downs, it goes with the fill in the order that I mentioned. There was this travel, it came back and finished the color and did the starting columns, and then the yellow will actually be black in our patch. This is the stuff when it was finishing the border of the patch. Okay. Now, when you're actually making this thing and how the patches that are here somewhere were made, this is kind of unusual. You hook in only the stabilizer. Usually you would have also your t-shirt or so within the hoop. For this thing, this is a special water-soluble stabilizer. So you can later easily get rid of that when you no longer need it. This one is kind of on the thicker side because you need to be able to work with the stabilizer only. So this is accommodating for the fact that we don't have 2 layers, fabric plus stabilizer, only stabilizer. Now, the first step is the outline, and because those binary codes can be attached to the machine, you can stop the machine there and add the patch. So you would glue it on top, do a tack down, and embroider the rest of the patch, like how we saw in the video. And you can remove it, do the finishes, and that's it, right? I made some selections that I will have on the slides online. Now, there's a few interesting things that you can do. One is generative designs. Inkstitch is a program written in Python, so you can write your own Python, right? There's an underlying library. This is a super easy example. You can add a bunch of blocks. Those blocks are basically coordinates. The thing works in 0.1 millimeter. So this is a super simple design that does like the outer width is like 3 by 3 millimeters, right? I wanted to add something else, so I took some fractal, and basically you can give an order, combine the points. And also, because there is a bunch of things that we wanted to remember about, there is those lockdown stitches, right? So tie-ins, tie-offs, program will add them for you. So if you have a design, let's say you're making that NFC antenna, right? If you dial in the parameters, you can basically generate your own design and like go from there without even opening the program. The other thing that's like super interesting, there's specialty threads that you can work with. Very quickly, there's like metallic thread that's well known. There's also different types that have different properties. Photosensitive, it will change under UV. There's also glow in the dark that will start glowing, in the dark, right? There's reflective thread. And one super useful type is conductive thread that I wanted to look at kind of in more detail. This is a list of a few types that I find useful in increasing usefulness. The first one is the steel conductive thread. This is the type that you could get from Adafruit or so early on. I think it's good for like hand sewing or maybe connecting to a PCB, but at least in my opinion, I would not put it in like a home machine because it will be hard to go through this whole mechanism for adjusting tension. There's a cutter in the machine, so the scissors will have a hard time, and so on, right? There is also some spools that you might find over the internet. They are marked conductive, but they are conductive somewhat, but they actually don't have the properties that you want, right? So, and the thread is basically twisted from like different fibers or filaments, and this one is twisted from some synthetic, probably nylon or polyester, and it has like a very thin steel core. This is maybe good enough for dispersing static, but it's probably not good enough for like conducting anything or so. There's a different type that I was able to get AliExpress basically. This is the type that's synthetic, and it's marked as conductive, and it's done differently. It's sprayed with like probably some metal oxides on top, and that gives it some properties. It likely gives it enough capacitance to work as a touchpad, but it's probably not good for actually conducting electricity. But you can still do like an interface for your project, right? There's another one, and now we're moving into the brand names. There's Madeira, which is like a well-known brand in the embroidery world. They have the series HC40, and the thicker one, HC12. So these are proper like polyamide filaments sprayed with silver, and they actually, we'll look at the details in a second, but they actually conduct pretty good. So you can actually do something interesting with it. There's also Amman Silver Tech. This is something that's hard to get if you're not a business, and I couldn't get it. And there's also, surprisingly, some stuff on Amazon that you can get. I didn't want to put any particular names in here because they tend to rotate historically, but you can get something for cheap to try out in your local makerspace or so. So quickly on the properties of the Madeira thread, max 9 volts. You can do 100 or 300 ohms per meter. So this is the resistance. Probably go lower when you have a different type of stitch that like locks onto itself and you have like multiple touch points, right? But resistance grows with the distance, basically, right? Of course, not insulated, and because it's sprayed with silver, if you like run close to those to the high end of those properties, the thread itself would deteriorate, right? So I would probably like stay on the lower side. But still, it's like pretty good for some LEDs or maybe an MCU that's like super low power or so. Yeah. Okay, and one thing that I wanted to point out, because we might lower the resistance when we do denser stitching, then there will be like more heat buildup, and we're working with, I don't know, cotton or so, and that fabric might get hot, and that might also be a problem for your particular application. And one thing that I wanted to add, that actually you can sew for PCBs on an embroidery machine, and like that's super useful for your projects. So there is a nice project that you can try out without making anything on your own called Glow Stitch. I think it's Maker Queen Steph or Stephanie. Huge kudos for that project. She made flex PCBs. They don't have any kind of stiffener, so it's like super thin polyamide, yes, and machine goes like straight through those. So you take the conductive thread and you just go through it, and it works perfectly. So you can imagine reading the docs. Like there's like some suggestions on how it should be done. I think the only interesting thing is that you need nickel gold finish, so it's like flat for the machine because the thread is actually not attached, right? It's not soldered to the pad, so you need like nice flat surface. But having known that, like I guess many people here know how to make flex PCBs, right? So you can drop a microcontroller in there. You can have, I don't know, time of flight sensor, like whatever you want, and suddenly you can have like non-planar designs and many different applications that I didn't even think about. Okay, that's just a close-up of how it works. So you can see that the needle actually pierces through, right? And there's like nothing that you would need to accommodate for. In this particular design, this running stitch is again a technical use, only to know where to position the flex PCBs, because you probably want to stop the machine and like put them at the right time. It would be risky, like sewing through whatever you have on that PCB, right? So you stop when it's actually attached to the board. You can just like go straight through it, and it will work. And kind of obvious, but you can also go through paper. If your machine doesn't have sensors, you can use it as a cutter of sorts, or doing perforations, and so on, right? That's everything I had for today. I have the slides up, and I also have the code up if you want to try some code. Also in the repo there is this patch, so you can see like how all of this was made, like what parameters were used, and so on. Also, please ask me questions now or whenever. Like I really like helping people. We're actually digitizing something on Friday with someone, so super cool experience. And yeah, thanks again.